Welcome, my name is Shaun Brazelton, and today I'll be discussing the effect of prolonged mild hypohydration on hand grip strength in females. Human performance can be reduced during hypohydration, which is defined as a state of low body water. Some of the most common causes of hypohydration are sweating due to heat stress or inadequate fluid consumption. Only one study has investigated the effect of hypohydration on strength in females. This study reported that passive heat stress-induced hypohydration reduced upper body muscular strength in resistance exercise-trained females. Despite these important findings, it remains unknown whether hypohydration due to inadequate fluid consumption and independent of heat stress also reduces strength in females. Therefore, the purpose of the present study was to test the hypothesis that maximal isometric hand grip strength in females is reduced following a prolonged mild hypohydration compared to a hydrated state. This study is currently ongoing, and today I'm presenting our preliminary findings from 6 young, healthy females. Each subject completed 2 experimental trials in a randomized crossover design. In one trial, subjects were in a euhydrated state, meaning that they were normally hydrated and consumed normal fluid and food intake prior to the trial. In the other trial, subjects were in a hypohydrated state, meaning that they were deprived of all fluids and high water content containing foods for 24 hours prior to the trial. Examples of foods subjects were not allowed to eat were fruits, vegetables, yogurt, soups, and sauces. As I previously mentioned, there has only been one previous study to investigate the effects of hypohydration on upper body strength in females. While the findings of that study were seminal and are an important step toward better including females in research studies, a limitation of that study was that it only included females that were normally menstruating and not on hormonal contraceptives. In the United States alone, approximately 47 million women use hormonal contraceptives, which represents about 65% of adult women in the US. Therefore, to improve the ecological validity of our findings, we recruited females that were using hormonal contraceptives in addition to females not on hormonal contraceptives. The data I'm presenting today is on 2 females that were not on hormonal contraceptives and 4 that were taking hormonal contraceptives. Following 24 hours of either euhydration or hypohydration, subjects arrived at our lab to undergo hand grip strength testing. Subjects performed 3 maximal isometric hand grip contractions with verbal encouragement from the research team and 1-minute rest between attempts. Importantly, this is a well-validated test in the literature. We assessed hydration status as a % change in nude body mass from 24 hours before the trial to the start of the trial to account for changes in total body water. Additionally, we measured urine-specific gravity, which measures the density of urine compared to water. Hand grip strength was evaluated as both the maximum force produced between the 3 attempts and the average of the 3 attempts. Before presenting our findings, I would like to orient you to the figures on the right side of the poster. For all figures, the bar graphs represent the mean values with error bars for standard deviation. The blue bars on the left side are the euhydrated trial, and the red bars on the right are the hypohydrated trial. The symbols connected by lines overlaying the graphs represent the individual values. For hydration status, we saw about a 1.6% greater reduction in body mass in the hypohydrated trial, and for urine-specific gravity, we saw an increase of about 0.016 from the euhydrated trial to the hypohydrated trial. These data confirm that the fluid deprivation protocol was effective at inducing a mild hypohydration. Both maximal hand grip strength and mean hand grip strength show a trend toward reduced strength with hypohydration, with 5 out of 6 subjects seeing reductions from the euhydrated trial to the hypohydrated trial. So far, both measures have shown roughly 10% reductions in hand grip strength with hypohydration. To conclude, our preliminary findings suggest that inadequate fluid consumption may reduce hand grip strength in females. Future studies may investigate whether these reductions in hand grip strength are exacerbated by additional stressors such as heat stress or physically demanding work. Thank you for listening.